everybody dead quiet. Yes?
Database tuning advisor.
Yes.
The behavior I've noticed is that if you use it and you put in a low stress on the system,
Yes.
it doesn't really come back with much.
No, it doesn't. And that's
Put a high stress.
yes. Yes.
It's a very different behavior.
It does, and you're right. And you're right. You need to stress. You need to be able to stress your systems, and it becomes a bit of a difficult thing because not all of us have lots of testers, and so where we do a lot of that testing is when we when we push our software out to UAT, which goes out every month. Then we've got many users coming in and starting to use it, so that's how we do a little bit more of that. Or if you've got some way of stressing your database, some of the test platforms allow you to run the same things over and over from different angles, using the simulation of many users. But you're right, because what Database Tuning Advisor is really doing, if you have a look at when it runs and it does a lot of stats. It goes and looks at all the queries, and it says, this one is being called a lot, and this one's not being called a lot. So you could often get away with an index that's required because you're not testing that use case, and Database Tuning Advisor will tell you you don't need an index on that particular table because the system's not under any stress. If you've got a lookup table with maybe 5 or 6 columns on there, you'll find the Database Tuning Advisor doesn't tell you to index that because it's happier just to do a table scan as opposed to an index seek. Does it make sense? Yeah. Any questions? Varun?
When creating non-clustered indexes, you can specify more than one column.
Yes.
Does that differ, or how does it compare to creating individual indexes per column?
It means, okay, so the question is, when you created a non-clustered index, you can say, I'm creating a non-clustered index with this column, this column, this column, and this column, all right? And that's what a covering index is. It's when you create quite a wide non-clustered index. And Varun's saying, okay, what is it individual? What happens if we just do individuals? Well, the problem with doing an individual is that if you've got more than one criteria, SQL's going to use the one it finds that's the best to fit just for that one index. And generally what you've got to try and do with your non-clustered indexes is make them fairly wide so that they cover most of the where clauses. So if you can think about your non-clustered indexes should be, if you've got a where clause that is where commission is equal to this and the ID is equal to this and this is equal to that, that should be the index that you start looking to create. And you should be trying to make sure all your where clauses fit in to that same index. So if you're creating lots of individuals, well, you're going to get very fast finds for where you're just looking for the one value. Where you've got more than one value, SQL will try and find the best one, but you're not doing an optimal. Then you're doing an index seek or index scan, as opposed to a seek, which is, the seek is just like straight to the record, and a scan is, I'll get as many of them as meet the criteria, and then I'm going to actually do almost a table scan and walk through everything to find what I'm looking for. Does that answer your question?
But what if you change the positioning of the conditions? Would you have to create a new index for that, or would SQL know exactly what?
If it's sufficiently different, it'll do a table scan. If it's not sufficiently different, SQL will try and find the best fit. But it starts at this point. So if you start ordering in the reverse order, it'll do a table scan. But if you had your first where clauses were pretty much the same and then your last two changed, you swap them around, it will do an index scan using as much of the index as it can. But if it was completely different, there is no signature that matches it, and it's then into your table scan. And I don't know, 1.18 million records. It's going to be a... Grant, you had a question.
Yeah, earlier on you spoke about performance from a cache point of view and this point memory perspective. And the solution was to break it up into multiple tables. How does that compare to, affect, when you look at data from performance and you look at joins, because joins are also something that affect performance. So how do you balance? What should you err? Should you err in memory, or should you err with?
It's a very good question. Sometimes it really does require a lot of thought around your data pattern, because it requires the thought around, this is personal information that I'm going to use quite a lot, and in that particular case, I used the information that I was going to use quite a lot, the personal information. Because it was an HR system, they needed to find the personal information, because that's what you're running reports off all the time. That came into one table. If you move it, and then professional information, which was, this is his job description, this is his history, this is where he's been, that was separated into a separate table, which wasn't used as much. But you're right, it would affect the join, but it's trying to separate the patterns based on the use case. I don't think there's one silver bullet that you can say that you have to do it like that. I think it requires thought around how to do the data pattern. And the miscellaneous stuff, as you saw, was the stuff you queried every now and again. And pull that out. If you start moving into a more into a different type of pattern, and I'm hoping that at some point we can start talking about big data systems, because the architecture underneath those systems is very different. But if you start moving into those systems, is you could actually create views that are created overnight in some sort of batch process that pulls out the information and creates the view that you want to be looking at, saved away so that it's an optimal read from that perspective. So there are different ways to get in. And I think what you need to understand, guys, is that when you're writing enterprise solutions, it requires a lot of thought. Your structure and what you're doing requires a large amount of thought. Any more questions?
Shy away from going to a view with breaks then.
I don't know if I have a one size fits all. We would generally try and reduce the number of joins, because you're right, it does put a performance hit on the system. But there's a lot of other things that are in that system. If you have a look at that table, if you shied away from joins, then you're wasting memory and you're wasting disk space. So there's a fair amount of management that needs to be put into place, and a lot of thought around what you're doing. Yes, sure.
You split it up into different things.
Yes.
But what if you add a view and just selected those columns that you need?
What happens if we added a view? And the problem is, a view could potentially be one way to go. The problem with that particular system is that I was wasting space on the disk. And I was wasting space in memory. So even if I pulled the data out, that data was going to go into memory, and it was going to take up a large chunk of memory, which something else could have actually used. And that becomes a bit of a problem, specifically in these large transactional type of systems. So I don't think a view would have saved me in that particular case. It wouldn't have been a good option.
So do you create any extra anything beyond just being a wrapper around?
Views can be indexed. So yes, you can. So that's also a very, very powerful feature, is to be able to take the data, create a view, and then create a separate index on that particular view, and then use the data from the view. Remember, the index applies to the view, not to the data. All right. Any other queries, questions? All right. Thanks, guys.